Okay, so this is the effect we are going to work on today. So actually this is not a realistic tornado by any means. It's just a study on like how to use different modules in Niagara simulation system to implement something like this. Just more like a study on Niagara. So right, let's see how to implement this today. Right, now let's get started with the Niagara system like this. New system from selected emitters, and I'll use this fountain effect, fountain emitter. Finish. Let's name it NS Niagara. Sorry, not Niagara. NS tornado. Okay, so this is what we have. So for the tornado we don't need the gravity force, so let me just disable that. And what else? And also we don't need this add velocity in cone, because in a tornado, in the particles of a tornado, we don't have right. And let's add this torus location module. So here we can use it to give some, we can use this to achieve some tornado like particle behavior. So okay, let's set this torus distribution mode. First make this array. Right, now we have the circular shape, this set direct. Now you can see it's one line. That's because this u position is constant. So if I link this to particle edge, now you can see there is a circle. So this kind of have the starting to have the tornado behavior, as you can see. So this should move up. So to make it move up, under advanced settings we have offset. So let's turn this to vector, and here we need to change the Z location with time. For example, if I make it 50, you can see that these particles are moving upward. If I make it 1, there is a small change. If I make it 10, see, let me increase the spawn rate bit so that we can clearly see the pattern. Right, now as you can see here, it's only starts from this point, but instead it should start from all the directions. So for that, here we have this normalize angle around torus axis. So this is, if you hover over this, you can get the tooltip 0 to 1 value for the angle around the torus axis. So here torus axis is Z1, so up direction. If I make it 1, you can see it's same. If I make it 0.5, you can see it's going in this direction. So as you change this value, you can see it's rotating around the axis. So here, instead of giving a fixed value, we can give a random float, random range float in between 0 and 1. Now you get a value like this, a shape like this. Right, now to get the tornado shape here, let's modify the radius, the large radius, based on the age of the particle. So that means particle spawns from here and it's moving upward. That means its age becomes higher, age value increases. So as it increases, this radius in the torus should also increase to have a proper tornado like shape. Right, so for that, let's use a curve here, float from curve. So if I make it like this, you can see this is the shape. So instead of decreasing the value, let's set this value to 2. Right, maybe something larger than 2. 3. And let's scale the curve with 5. Okay. As I increase this value, you can see the shape changes. So I'll use the shape 5. And what if we change this shape, turn this into a auto, right. Now as I move this part closer, you can see the shape becomes more like a tornado. Now let's drop this into the world and see how it looks. Okay, it starts to look like a tornado. So the next thing is, as these particles go up, they should become larger. So we can do that. Scale sprite size. So here let's use a curve. Scale vector 2D by curve. No, undo. Curve, let's use vector 2D from curve. Okay, and this is also using the normalized edge. So here, let's make this 3. And Y also, so X. Both X and Y, I make the same value like this. Not enough. Here also we can make it a curve like. Let's scale the curve with 5. Maybe a bit too much. So what's the age of the particle? Point seven, no, 1.4 to 1.75. Right, then this should be fine. Oh, we can add another key here. Make it auto and move it like this, so we can keep the initial sections. Initially we can keep the sprite size small and make it larger as it moves up. Okay. Oh, well, this is one alert. Right, that's better. Let's further increase this size. Let's say 9 and see what happens. Yeah, that looks much better. Alright, so what's next? So I think this should have some variation in the axis instead of like facing it directly up all the time. So for that, I think we can add an offset here. Let's see, if I make it 5, you can see it's angled to the left, -5 in this way. Similarly in Y it should move forward, yeah, bend forward. Okay, so we can use this. So here, instead of having a single value, let's add a dynamic input, multiply float. Here as the first parameter I'll use a sine. So sine is coming from emitter edge, and multiply it. Oh wait, we don't need a multiply float here, just a sine should be enough. The reason to use sine is because sine gives a value in between -1 and +1. As we use time as the parameter, sin t will be changing from -1 to +1. So here, scale, let's try 5. Twice. That doesn't make a change. So to see some real variation, we might need to have a scale larger than 1. So let's try 10. So here you can see a real difference, but it's too much. So let's use 5, and as the period, let's 5 should be enough actually. maybe not, like it's too fast. Let's try it and reduce the scale to 3. Okay, let's check here. Right, let's do the same thing. Copy, paste to Y as well. Right, now you can see it's changing its direction. Great, so I think this should be enough for today, but let me fine tune this sprite size a bit. Yeah, I think I like this version better. Okay, so here is our tornado, and if I move it like this, you can see it's not initially also it has some radius. So yeah, that's a minor detail. So right, so I'm gonna stop this episode right here, and thanks for watching. So as always, project files will be available for the download in Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.